In this video lesson, we will learn two new methods to show that two triangles are similar. They are side-side-side and side-angle-side similarity. Let's look at the first one. The first being side-side-side similarity. If the corresponding sides of two triangles are proportional, then the triangles are similar. We have with us the two triangles, this example. We have triangle ABC and triangle XYZ. We want to determine if the two triangles are similar. So we check for proportionalities. We don't have to know anything about their angles. So my rule of thumb is always to take the larger one of one triangle and set it up in a ratio with the larger one of the second. So we would have 18/12. Then take the smaller one of each, set those up as a ratio. And then we would have the leftovers. Remember our rules of proportions? We can check for cross products, or we can check to see if all ratios would reduce to the same number. Here in the first one, 18/12, there's a common factor of 6. We get 3/2. 12 and 8, common factor of 4, reduces to 3/2. And in 15 and 10, we have a common factor of 5, which reduces to 3/2. What do we know? We know that all the sides are proportional. Thus, we can conclude that triangle ABC is similar to triangle XYZ. Now, since all of these values, and this is the way it needs to be, all the values from one triangle are on the top side. That is how the scale factor is set up. All X, Y, and Z factors are on the bottom. So the scale factor here is 3:2. What is the scale factor? It is 3:2 in that order. ABC to XYZ, setting up the scale factor. Remember, anytime we are testing for similarity, we want to, if we can define two triangles to be similar, we then would like to find the scale factor. And hence we have done that here. Let's look at another example. Something similar. Here we have multiple triangles. In this case, we would like to determine if what two triangles would be similar to what two triangles. We have triangle RST with the following values of 9, 6, and 12. Obviously not in that order. Here we have side lengths of 4, 6, and 8. And lastly, we have 6, 10, and 14. Of course, we always have the disclaimer. They're not drawn to scale. We know that. So we want to check for proportionality. So the way that we do this, we want to determine if RST is similar to LMN or DEF, or if LMN and DEF are similar, whichever case may work. So look at the ratios of the corresponding sides. How do we know they're corresponding? What was our rule? Yes, we want to find the smallest one over here. Well, let's set it equal or in a ratio with this smaller one, 6/4. Then we're going to take the larger one here with this largest one. So that's 12/8. And then we have the leftovers. We want to see if they are indeed proportional. Well, we want to set it up as an extended proportion. Check for similarity. 6 and 4 has a common factor of 2, reduces to 3/2. 12 and 8, common factor of 4, reduces to 3/2. And 9 and 6 has a common factor of 3, which also reduces to 3/2. Thus, we can conclude that triangle A is similar to triangle B. Now, we can call them different triangles if we would like to in some cases. If we were having to write a similarity statement, triangle, let's say RST is similar to triangle. Now, RS corresponds to this side over here, which would be LN. We are not fortunate enough to go in alphabetical order in this case. And our scale factor would be 3 to 2. So let's check to see if this triangle of DEF would be similar to the other two. Checking for it. The shortest side here of 6 over 6. Looks a little intriguing. We know that automatically reduces to 1. So when we look at this larger one of 14 over 12, we can stop right there. We have found one set of sides not proportional. So we know that these two triangles of RST and DEF are not similar. Well, what about triangle DEF and triangle LMN? Here too, we can check for proportionality. Take the smaller one, 6 to 4. The larger one, 14 to 8. And we can set the leftovers equal to each other as well. Common factor of 2 reduces to 3/2. Here our common factor would also be 2, and that reduces to 7/4. Notice right there, we don't even have to check 10/6. We have found one set of non-proportional sides. Thus, we can conclude they are not proportional or they are not similar. Only triangle RST is similar to triangle LNM. And we will look at the other theorem, side-angle-side similarity. If an angle of one triangle is congruent to an angle of a second triangle, and the length of the sides that include these angles are proportional, then the triangles are similar. Inclusion. Keep that in mind. Remember what inclusion means. The angle here must be between the two sides given. Angle between the two sides. This angle is made up of the two sides that we are given. So we set our corresponding parts in a proportion. Larger one here of 15 over 10. Smaller one of 12 over 8. We check to see if they are proportional. We can do our cross products, or we can check for a reduced fraction. 5 goes into both 15 and 10. It reduces to 3/2. 4 goes into 12 and 8. It also reduces to 3/2. Since our sides are proportional, we have congruent included angles. We know that these two triangles are similar by side-angle-side similarity, and our similarity statement would be triangle ABC is similar to triangle XYZ. Our scale factor from ABC to XYZ would be 3 over 2. Another type of side-angle-side similarity may include overlapping triangles. When this happens, we either can identify the separate parts, or we may have to actually draw them. Do a quick sketch. If we look at the smaller one inside, we have triangle BDE. Triangle BD, oops, supposed to be a D, E. And this side is 4 units, this side is 5. Then we have the larger triangle, the whole triangle of triangle BAC. Now, side BA is not just 8. It is the combination of 8 and 4, because 8 is the length from D to A. So AB or BA would be equal to 12 units. We would add, combine 8 plus 4 to get 12. So these two together equals the 12. And over here on this side of BC, yes, we would have to combine both 5 and 10. When we combine those two, what do we get? 15. Now, here we're only given two sides. Do we have an included angle? Well, if you understand and note that angle B is included in both triangles, we know that this angle B is the same as that angle B. Thus, we have side angle side, side angle side. So we need to check for proportionality. The larger one, 5, over the larger one of 15, equals to the smaller one of 4 over 12. Check our cross products or simplify. 5 over 15 reduces to 1/3. 4 over 12 reduces to 1/3. They both reduce to the same number. They are proportional, meaning the two triangles are similar by side angle side. Our similarity statement, triangle BDE, triangle BDE would be similar to triangle BAC. Our scale factor would be 1 to 3, and remember our justification, side angle side similarity, all the same. So what have we learned today? We have learned two additional shortcuts to prove that triangles are similar. We no longer have to show all corresponding angles congruent and all corresponding sides proportional as we would with most polygons. Here with triangles, we can shorten the process, which is what we always like to do, having shortcuts. So hope this was good for you. Hope you learned something, and look forward to seeing you in class the next time.